Welcome to The Explainer. Today, we're going to follow the amazing journey that blood takes through your body, every single second of every day. It's a massive, complex highway system, and we're jumping right in.
So let's start with a big question, right? You've got trillions of cells, and every one of them needs oxygen to live. It's like a massive city that needs constant deliveries. So how on earth does your body manage this incredible logistics operation? Well, that's what we're here to find out. Here's our game plan. First, we'll start the mission. Then we'll hit the exchange zone, where all the action happens. We'll tackle the tough uphill climb, map out the two huge circuits, and finally, find out why you are so important to this whole process. All right, let's meet the hero of our story, the red blood cell. I want you to think of it as this tiny little delivery driver on a mission that is, quite literally, a matter of life and death.
And its job description? It's pretty straightforward, but absolutely critical. It has to deliver the good stuff, oxygen, nutrients, and then it has to pick up and haul away the trash, the metabolic waste. This is a non-stop 24/7 gig. No breaks.
Now, for that delivery to actually happen, our little red blood cell has to get off the main freeways and navigate the tiny neighborhood streets, and this is where it all goes down, deep inside the capillaries.
So what are capillaries? They are the smallest, most numerous blood vessels in your entire body. We're talking about a network of around 40 billion of them, so dense that no cell is ever far from its own personal delivery route. But just saying they're small really doesn't do them justice.
So how small are we talking? Well, it all comes down to this number, 1. A capillary is so incredibly narrow that only one single red blood cell can squeeze through at a time. They literally have to line up single file. And you know what? That's not a bug, it's a feature. It's designed to slow things down right where it matters most.
Because this slow, single-file line is exactly where the exchange happens. As our red blood cell inches past a tissue cell, it makes the drop-off. It hands over its precious cargo of oxygen and nutrients. And at the exact same time, it picks up the cellular trash, carbon dioxide, and other waste. It's a perfect, incredibly efficient handoff.
Okay, delivery's made, trash is collected, mission accomplished, right? Not so fast. Now comes the really hard part. Our red blood cell has to get all the way back to the heart, and for all the blood down in your legs, that means fighting against gravity. It's a true uphill climb.
So, how does the body pull this off? Well, first, it uses some seriously clever engineering. Your veins are equipped with these tiny one-way valves. They're like little trapdoors that let blood flow up towards the heart, but slam shut if gravity tries to pull it back down.
But see, those valves need some help. They can't do it all on their own. And that's where the muscle pump comes into play. Check this out. Every time your leg muscles contract, when you walk, when you move, they squeeze the veins nearby. That pressure pushes the blood up. The valve above it opens up, while the one below closes tight, making sure the blood only goes one way, up.
And this right here is why it matters in your day-to-day life. You ever get that heavy, achy, swollen feeling in your legs after sitting for a long time, like on a plane or at a desk? Well, that's your muscle pump being offline. When you don't move, those muscles aren't squeezing, and blood starts to pool down in your lower legs.
Okay, so we've seen the tiny side streets and the tough climb back. Now, let's zoom all the way out and look at the whole highway map. Our red blood cell's entire journey is part of two huge interconnected loops.
So, circuit number 1 is the pulmonary circuit. Think of this as the pit stop for refueling. The tired, CO2-rich blood comes into the right side of the heart. From there, it gets pumped over to the lungs, where it drops off all that carbon dioxide and picks up a fresh tank of oxygen. Then that re-energized blood zips right back to the left side of the heart, ready to go. And that brings us to the second loop, the systemic circuit. This is the main event, the big delivery route to the rest of the body. All that fresh, oxygen-rich blood is pumped out of the heart's left side with incredible power. It travels through the aorta and then out to every single organ, tissue, and cell. After it makes its delivery, the now CO2-heavy blood makes its way back to the right side of the heart and, you guessed it, the whole cycle starts all over again. So after seeing this whole incredible journey, we get to the most important part. The heart is obviously the main pump, but it doesn't work alone. It has a very powerful partner in all of this, and that partner is you. That's right. Every time you get up and move, you are actively helping your own circulation.
You're firing up that muscle pump we talked about, you're helping to push that blood back up against gravity, you're fighting that stagnation, and you're getting rid of that heavy leg feeling. You're basically making the whole system run smoother, making sure every cell gets what it needs to thrive.
So, the big takeaway is this. You're not just a passenger along for the ride. You are a crucial part of the engine. Every step you take is helping to power this amazing system. So, what do you say? Ready to give your heart a hand and go for a walk?